Okay, welcome to this video tutorial for how to set up the water rocket simulation in Unity. So the assumption is that you've successfully downloaded Unity and managed to run some example projects in it. Now you're at the stage where you want to import the rocket simulation project and get going with the simulation itself. So to do that, we need to create a new Unity project, and we're going to open the Unity Hub, and we're going to create a new project. So this can be a little bit confusing, but in this dialog box here, you need to say where you want to create it and the name of the project. I'm going to create mine here in the downloads folder just to keep it out of the way because it's going to be temporary, but you need to use this as a place where you store your files. As a bit of a caveat, Unity doesn't necessarily work very well with Dropbox and some other online backup situations. So if you're having problems, it may be better to store this outside Dropbox because, as I say, Dropbox gets in the way. I've just got this here as a temporary measure. So we're going to call this Water Rocket Simulation. Let's call it version 3.4 for me. Doesn't matter what you call it, but something that you happy with, and it will now create the file. I noticed then I actually forgot to tell it which Unity version to use. Just to be clear, you need to be using 2019.4, so that's the standard default Unity installation, which hopefully is the one you've got. It just makes it easier if everyone uses the same version as Unity. Okay, and if it all goes to plan, Unity should start just with an empty project. The name up here is the name that you gave it, and this sample scene is just the default scene it always loads with nothing in it. And one thing we need to do first before uploading the simulation is to install a package called ProBuilder, and it's a standard add-in for Unity, and in the rocket simulation we use that to enable you to edit the size and shape of the fins, and it's also used for the scenery. It's a little extra step, but it's something we have to do. So if you go to Window and then Package Manager, you need to let it sit for a bit to find the packages. It'll sit there spinning a bit while it's looking what's available. Then you need to find the package called ProBuilder. You can search for it up here, but it just so happens this one's come out where I can see it. So it's here, ProBuilder, and I've selected on that ProBuilder, says something about it, and then this button here, Install, this will install the package that I've selected over there. So I'm going to click Install, and it's going to trundle away, and what this does is add some extra capability to Unity so that you can easily edit meshes. So it's getting that from the internet, and it's now importing and installing it. Okay, so it's finished, and all we have to do, we can just get rid of that window. Okay, so now we've set up Unity. Now what we have to do is install or import the asset pack, which is the simulation itself. So if we go to Assets, Import Package, and then Custom Package, it'll open up a dialog box and we can find the bit we want to use. So you'll have downloaded the simulation pack from Blackboard or wherever site you've got it from, and depending on what version of package you've downloaded, you need to navigate to that, whether it's in downloads or whatever. I've got mine here in student builds, and the latest package that I'm going to use is this one, so use whichever one is the most current version. So Water Rocket Simulation, in this case 3.3, but as I say, use the most latest one, and if we click on that, it's now going to drag all that stuff into the simulation. So here it's listed all the different things you can do, so these are all the different files in the project, and what we're going to do is just import them all. So that's the default option, importing them all. So just as a note, sometimes if you've got Dropbox on, if you're using Dropbox, it kind of falls over at this point because Dropbox tries to synchronize at the same time as you're uploading something. So once again, if you are having problems with errors at this stage, it might be something to do with where you stored your file. So say store the file not in a place that's being updated continuously. Okay, so that's gone in successfully. So what have we got? It's still on the default scene, which has got nothing in it, but if we go to the project window and then go to scenes, we've got 3 scenes there. This is the one at the moment. We've got Force Playground and Water Rocket. Before we start the Water Rocket, let's just go to this one here, which is just a sort of kind of hello world scene, just to get used to what's going on and to test things are working. So in this scene, we've just got a little orange cube in a padded cell so that it can't escape from. And there's a very simple script attached to it, or package attached to this cube, which allows you to apply forces. So if we click on orange cube in the inspector, this gizmo appears here. So this is important because it tells you which way the directions are. So it's always red, green, blue for X, Y, and Z. So if we apply a force in the X direction, it'll be in the direction of that red arrow. If we apply in the Y direction, it's that way, and Z direction this way. So as far as we're concerned, Y is up, X is sideways, and Z is backwards and forwards in that way. And this thing here, if we want to say look along the X direction, we can click on here, and if we do that again, that's a different way of doing it. Let's go around. Okay, so by clicking on that, it will rotate the view. So this is probably the most familiar view, where you've got X that way and Y that way, X and Y that way. Okay, and then I guess the important bit is if we look in here, there's this component here with a weight on it called constant force, and this is Unity's way of without any coding, just adding some force to an object. So the thing we're interested in here is applying a force in the X, Y, or Z direction, or a torque about these axes. So force, most important to start off with. So if we apply a force there in the X direction, it should make the cube go that way. If we apply a force that in the Y direction, it should make the cube go up. We've got gravity turned on, and the mass is 1. Set gravity is actually set to 10, acceleration of 10 meters per second squared here, so nice and easy. So what that means is that if we need a force of 10 newtons to make the thing go up. So let's click play, and we're now into the game mode, and there's some instructions here which you can read. So what we have to do is click on the orange cube if you haven't already done so, and in here we can now start applying some forces. So you can either type a number in there, hit return, and there's friction, so nothing has happened there. Let's increase it a bit more. Okay, so we've got a bit more force now, and the thing is being thrown against the side of the wall. And if we turn that force off by putting it to 0, it should fall back down again. So you may or may not know, but if you hold your mouse over one of these variables, you can just drag it and apply a force, which is sometimes an easy way of doing it. So let's set that back to, let's get it in the middle. And now if you want to make it take off, if we apply a force of 10, that'll just cancel out gravity. So it's just going up. But while it's going up, if we want to apply a torque, let's apply a torque about the z-axis. We can make it spin round or not spin round. If we put that back to 0, it will fall to the ground, and so on. And if we put the torque back to 0, it stops spinning. Okay, so really the point of that is just as a chance to make sure your interface is working with the uploaded file. You can have some fun just by throwing the forces around. Gets you interacting with the inspector here, putting in different values. Just have a play with it, really just to get things warmed up. Okay, so when you're happy with that, you know what you're doing, job done here. So to the main event now, if you go to the water rocket simulation, if you start that, starting in a slightly weird way, but if we go down the hierarchy and click on this and come out slightly, we can see the view. It started off below the horizon, so the floor disappeared. So what we have here is our rocket simulation. In the hierarchy view, if you click down, the rocket is everything below the launch pad in this hierarchy, but the most important bit is this simulation configuration, and these controls here are basically the things you need to vary to interact with the simulation. Well, without further ado, we can just try it. So if you click play, it should just run, and there's not a very good rocket on the launch pad, but it'll show you that things are set up and working. Okay, so that was a bit lame, but your job as a rocket engineer is to try and improve the design of that by looking at the different factors that make up the rocket and try and understand how it works. So bear in mind the goal here is about understanding how you can use simulation to improve designs, and quite a lot of this is just understanding how the effects of things like wind and build quality affect your choices, because you can in simulation build the most perfect rocket, but if it doesn't work when the wind blows, then that's an issue. So a quick tour around what you can do. These test mode here is the main way you change the interaction. So we've got free flight, so just as you've seen then, wind tunnel mode. If you then you do update configuration and press play, so this is now fixed about its center of gravity, and we've got the wind blowing left to right, and we can change the wind speed on here, make the wind go faster or slower, and we can also change the direction of the wind. So if the wind comes from down that way, so we can look at what happens when the rocket hits the gust, how does it behave. So this is not a great rocket, slightly clunky fins, not in the right place, but you get the general idea of how it works. Next up is the thrust test stand. If we play that, you can see the thrust test happening, and the black thing is the center of gravity, and as you're using the water up, the center of gravity rises, so that just shows you that the center of gravity of the rocket changes. So we can't really see much what's going on, but now what we want to do is use the plotting tool. So if you do Control G for grapher, it should make a window like this appear, and if we run the thrust test, you can see it there plotting the thrust against time, and if you move your mouse over this window, you can see it started off with a thrust of 42 newtons, and then it dropped down to a thrust of about 10 newtons at the end, and this is the time that the thrust was on, but this is factored by your slow motion factor. So at the moment we've got a slow motion factor of 0.5, so this time is stretched out by a factor of 2 longer than it would be. Anyway, so you can vary the amount of water in the rocket, and then you can see how much your thrust varies depending on the amount of water. And bear in mind, the important thing for how high the rocket goes is the area under this curve. So it's the area of thrust times time, which is the impulse of the rocket. So as you're varying the water fraction, you should be looking at how this area under the curve varies. Okay, so the last one on our list is the drop test, and we use this for assessing the effect of the parachute. So we just drop the rocket and the parachute will hopefully come out, and on here you can see what the vertical descent speed is for different parachutes. So here we've got a descent speed of -5 meters a second, so it's coming down pretty quick. Okay, and then once you've done all the individual ones, you can go back to the free flight mode and have a play with it. Interesting things here. Build quality goes from beginners stuck together with sellotape the night before or 5 minutes before to a precision build where everything is perfectly aligned. So one of the things to investigate is what happens depending on how you vary the build quality, because it's no good optimizing your rocket to make it perfect if a student has to build it and it's actually a bit wonky. So somewhere in the middle is probably realistic. The other thing to look at, let's move our fins down a bit, see what happens, a bit too far. And we can change the weather conditions. So actually on the launch day it might be a strong wind, in which case we've got 5 meters a second coming across. So if we just see what happens if we now launch in a strong wind. Okay, so we've got a general crash there. The grapher window is up, and I guess one of the crucial things here is this one here, this brownie one, is the egg acceleration. So this is the acceleration of the egg, and you can just about read off here of the values you're getting, but the thing you're looking at is in terms of a crash is what acceleration does the egg go through when it hits the ground. Anything more than about 10 G and your egg is going to break. Okay, I think that's about it. There's some other things. If you want to change the amount of time that you see in here, you can change it, change the length, horizontal time. So if you want a longer recording, you can put a greater number in there, up to 30 seconds, or you can make it shorter if you want. Okay, so get this installed, have a play with it. Your job as a rocket designer is to investigate how these different parameters of the position of the fins, size of the fins, length of nose cone, and so on affect the design, so you can go about trying to optimize it so that when you build an actual rocket it has the best chance of success. So good luck with that.